Building a secure network is probably top of the list of things to consider when building an infrastructure, ensuring that the user's information and their host devices are safe from any threat actors. In network security, it's important to have policies, processes, and best practices in place to help detect and mitigate attacks. An attack example being someone trying to gain unauthorized access to the local area network. Having an unauthorized host access the network could spell disaster for the network admin. It could be something as simple as someone having a laptop connected to the local area network and having a snoop around. Or it could be something malicious such as a man-in-the-middle attack, or a denial of service attack, or a rogue device running automated scripts to find vulnerabilities on the network and exploit them. So how can we prevent a rogue device from just accessing the network from an open switch port, for instance? Well, there's a few things we can do. We could turn the switch port off, or we could enable port security, enable a MAC ACL, or we could create a VLAN black hole. Another option is 802.1x port-based network access control. Let's take a look how we can set this up by using a DrayTek router, a Cisco network switch, and a Ruckus access point. Usually, and on most occasions, a user has a host device, whether it's a laptop, a desktop, or a mobile device, and they want to connect to the network. Well, they just get a cable and plug it in, or they connect to the Wi-Fi SSID and input the WPA password. But this removes the ability to control who can access the network and protect it from unwanted visitors. This is where 802.1x can help. 802.1x is an IEEE standard for port-based access control to provide authentication protocols to a host device that would like to access a network, whether that's via the wireless local area network or the local area network. In other words, for someone to connect to the network, they have to input a set of credentials to gain access. So how does 802.1x work? Well, it involves three elements: the supplicant, the authenticator, and the authentication server. A supplicant is a host device, a laptop, a mobile phone for instance, a device that wants access to the network. That is software asking the user to input their credentials to log in. The authenticator is the intermediate device on the data link between the host device and the network. This can be a network switch or a wireless access point. This device can allow or block the device from connecting to the network. It translates EAP messages into radius messages. More on this shortly. Then we have the authentication server, which is usually a server or device capable of running authentication software such as radius and EAP protocols. You could compare this to trying to get into a pub or a club, for instance. You are the supplicant and you want to gain access to the pub. The pub is the network. The bouncer is the authenticator, and they will take your credentials such as your driving license or passport and validate your details so you can get access. The bouncer passes your ID to the supervisor, who is your authentication server, checks your date of birth. If your details are valid, you get access. If your credentials are missing or invalid, you're rejected. So what is the authentication server? Usually it's a radius server utilizing EAP protocol. So what is radius and what is EAP that I've been going on about? Remote Authentication Dial-in User Service, or radius, is a client-server protocol that provides authentication, authorization, and accounting, or AAA, from a centralized management system such as a Windows or Unix server, and it grants users access to a resource or resources on the network. Radius is comprised of three components: the supplicant, similar to 802.1x, the host device; the NAS, or the network access server. This is the gateway between the user and the network, and is what prompts the supplicant for authentication. This is similar to the authenticator, the device living on the data link layer, an Ethernet switch or wireless access point. Then you've got the radius server. This contains a pre-configured onboard user database to cross-reference the credentials sent from the NAS. So to connect to a resource with a radius server on site, the user will input their credentials into the supplicant, a username and a password for example, and this information is then sent to the NAS. The NAS sends an access request message to the radius server, the username and password is contained within this access request message. An authentication check is made by the Radius server to ensure the information is using an authentication protocol such as PAP, the password authentication protocol, CHAP, the challenge handshake authentication protocol, or EAP, the extensible authentication protocol. The Radius server will respond with one of three messages: access reject, access accept, or access challenge. Access reject is when the user is denied access to that resource. This could be due to invalid credentials, for instance. Access accept is where the user is granted access, and access challenge is where the Radius server requests further information. Within these messages may be information on why the user was rejected. Maybe the username and the password was incorrect, or the user doesn't exist in that database. I mentioned PAP, CHAP, and EAP. Each of these are authentication methods. PAP is the password authentication protocol. CHAP is the challenge handshake authentication protocol, and these are protocols used to validate users. PAP sends authentication requests to the server such as a username and a password, and if it matches the credentials in that database, it responds with an accept or reject message. These messages are sent in the clear, including the username and the password. CHAP is still based on a shared secret. The authentication server sends a challenge message to the access requesting device, which runs the message and the user's password through an MD5 hash algorithm. The host device then returns the resulting hash string and username in plain text back to the server. The server then uses the username to look up the stored password in the database and calculates the same MD5 hash originally sent with the challenge message. If the hash matches, then the user is authenticated. If not, authentication is failed. EAP is the extensible authentication protocol, and it's a little bit different. It's more of an authentication framework to transport authentication methods such as EAP MD5, EAP TLS, EAP TTLS, and so on. Within the framework are 40 different protocols. The EAP framework is used by 802.1x. EAP as a framework does not flow through the wire or go over the air. So when it was adopted by 802.1x, it was extended to 802.3 wired connections and 802.11 wireless connections using EPOL, or the Extensible Authentication Protocol over LAN. The 802.1x protocol encapsulates the EAP data to transport authentication information from the supplicant, so the username and the password for instance, to the authenticator, then on to the authentication server. So just to recap, the supplicant is the host device usually running authentication software. The authenticator is the device between the supplicant and the authentication server, which is usually a switch or a wireless access point. This translates the messages between the two. And the authentication server is the Radius server. When you first connect the host device, so a laptop for instance, to the authenticator, if the authenticator has 802.1x enabled, the port will be set to an unauthorized state and will only allow 802.1x traffic to pass. Everything else is dropped, such as TCP and UDP packets. The authenticator will send an EAP request identifier frame on a unique layer 2 address, which the supplicant is listening for. On the host device, the supplicant will display a login request to submit an ID, usually a username and a password. When that is sent back to the authenticator, this is the EAP response. The back and forth messages between the supplicant and the authenticator is encapsulated within EPOL, the Extensible Authentication Protocol over LAN or Local Area Network. EPOL is probably something you've used many times without even realizing. When you connect to a WPA Wi-Fi network and input the password, EPOL exchanges the identities of the host device and the wireless access point to establish a secure encrypted tunnel. Anyway, the authenticator takes the EAP response and encapsulates it within a Radius access request packet and sends it to the authentication server, the Radius server. The authentication server replies with a Radius access challenge packet which contains a request on the EAP method the supplicant wants to use. This is sent to the authenticator. The authenticator translates and encapsulates the EAP request into an EPOL frame and sends it to the supplicant. The supplicant can begin using the requested EAP method or reply with the method it's willing to use by sending a negative acknowledgement. An EAP method example could be EAP MD5. But if the supplicant agrees with the EAP method, it sends an EAP response to the authenticator, which is translated and encapsulated into a radius access request packet and sent to the authentication server. If the supplicant and the authentication server can both agree on the methods, the radius server sends an access accept packet to the authenticator, which is translated to an EAP success message and sent to the supplicant. The authenticator then sets the port to authorize, and the host device has access to the network. If authentication is unsuccessful, then the port remains unauthorized. Simple. Let's put this into practice. I've got my setup here to try this on. I've got my DrayTek 2862 router, which happens to also have an internal radius server built in. This is my authentication server. I have a Cisco Catalyst 1000 switch. This is the 802.3 authenticator. And I've also got a Ruckus R310 wireless access point. This is the 802.11 authenticator. 802.3 is the IEEE standard for hubs and switches, and 802.11 is the standard for wireless local area networks. Then I have the supplicants or the host devices. I've got a Windows machine and I've got a mobile device. You might have to do some setup on the Windows machine to enable wired 802.1x. There are some tutorials online how to do this. Let's set up the authentication server. This DrayTek router is factory default, so we've got a fresh start. The first thing to do is to set up a user account. So under user management and user profile, I'm going to enable this account and give the username Sam. And just put in a password, something highly secure. I'm going to use the word pig and confirm the password. We can leave the login settings and policy, just keep it basic for now. And at the bottom is other services. We want this profile to be used by internal radius and local 802.1x. Press OK, and that is the account created. Now let's set up the radius server, the authentication server. In the menu, let's go to applications and radius. I'll click on internal radius and enable. Under radius client access list, I'll enable number 1, and I'll put in the shared secret. I'll put in monkey as the secret. This is the password the authenticator is going to be using. Now I can do a couple of things for the IP address. I could put the network address, so any device being the authenticator will be able to communicate with the server. But for this though, I'm going to put the switch IP address, so 192.168.1.50, and the subnet mask of 255.255.255.0. For authentication, by default, we have PAP, Password Authentication Protocol. In the drop-down, we've got PAP, CHAP, MS-CHAP, and MS-CHAP v2. These are also authentication protocols, so a username and password to authenticate a user. I'll select this so we have multiple authentication methods. Under 802.1x method, I'm going to tick Support 802.1x method. We have EAP TTLS PAP, EAP TTLS MS-CHAP, EAP TTLS MS-CHAP v2, and EAP PEEP MS-CHAP v2. Each of these protocols utilize the EAP framework. First is EAP TTLS PAP. EAP is the transport method and encapsulates TTLS. TTLS is the tunneled transport layer security. TTLS utilizes the transport layer security protocol to set up a secure tunnel. Phase 1 is the TLS handshake, where the supplicant requests authentication to the authentication server. It's during this phase the server will send its certificate. When the handshake is complete, a TLS tunnel is established, and the host device then uses another authentication protocol, which is PAP in this case, the Password Authentication Protocol. Then there's EAP TTLS MS-CHAP. The same encryption using TTLS, but using MS-CHAP. This is Microsoft's version of CHAP. MS-CHAP v2 had some improvements over v1 and has the option here for TTLS MS-CHAP v2. Then we have EAP PEEP MS-CHAP v2. PEEP is the Protected Extensible Authentication Protocol and is similar to EAP TTLS and uses TLS to encrypt the tunnel between the client and the authentication server. The best authentication method is using TLS certificates. EAP TLS uses TLS public key certificate authentication mechanism within EAP to provide mutual authentication of client to server and server to client. With EAP TLS, both the client and the server must be assigned a digital certificate by a certificate authority that they both trust. But for this demonstration, I'm going to tick EAP TTLS MS Chat v2, EAP PEEP MS Chat v2 as well. Then I check that my user profile, Sam, is in the authenticated users list and press OK. Now we can set up the authenticator, which in this instance is my Cisco network switch. In the web UI of the switch, I'll go to Services, Security, and AAA Server. I need to add a new Radius server for the switch to be the authenticator. Press Add and use the protocol Radius. In name, I will leave this as Radius_1. The server address is the router, and the shared secret is Monkey. The ports the DrayTek router supplied was 1812, so I'll put that in and save and apply. Then under access policy, I set the ports I want to have 802.1x enabled on. So for this, I'll set port 1, which has got my Windows laptop on it. Now that's done. Over on the Windows machine, I'll generate a ping to Cloudflare. If I connect the cable to the Ethernet port on the laptop, I still get a ping transmit failed, but I get a login box pop up on the screen. The authenticator is blocking all normal traffic and only allowing 802.1x to pass through, hence why I'm seeing this login screen. This is the supplicant. I'll type in my credentials, so the username is Sam and the password is pig. Then after a few seconds, I get responses from both addresses I'm sending a ping to. That's the hardwired element of 802.1x. Now let's do Wi-Fi. In the DrayTek, I now need to tell the Radius server to allow another authenticator in the Radius client access list. I'll input a shared secret of Monkey again, and the IP address of the Ruckus wireless access point and the subnet mask. So in the Ruckus access point, let's log in and go to Admin and Services and AAA Servers and click on Create. For the name, I'll call it Office Radius and the type is Radius. The authentication method, I'll choose CHAP and the server address is 192.168.1.1 and a port of 1812. Re-input the shared secret, Monkey, and press OK. I can give this a test now. If I go to Test Authentication Server Settings, Test Against Office Radius, and input my user name and password, hit Test, and it returns with a success message. So we should be good to go. Now let's create a Wi-Fi SSID and put this authentication against it. Under Wi-Fi, I'll click Create. For the name, I'll put Office Wi-Fi. Usage type is standard, but for the authentication method, I'm going to choose 802.1 EAP. Encryption is WPA2, and the authentication server, Office Radius. That's all I need to do now. Click OK, and now I can wait for the SSID to appear on my mobile device. So I'll search for the SSID. I can see Office Wi-Fi. When I try connecting to it, it prompts me for a username and a password. To show this working, I'll input the wrong credentials. I'll put in Gareth and a password of Office. And it says unable to join network. So now I'll put in the correct details. I'll put in Sam and Pig. And we're straight on. No issues. I'm authenticated to the Wi-Fi network and I can now get out to the internet. 802.x is probably one of the best methods to ensure users accessing your network are authenticated. But what about devices like printers, media streaming boxes such as Apple TV, Nvidia Shield or Roku that might not have 802.1x capabilities? Well, With these ports, we can enable port security, where the MAC address is learned by the switch. So if someone came along and unplugged a printer and plugged in their laptop, they wouldn't get access because the new MAC address does not match what the port has learned, so access is denied. I have an entire video on port security that you can check out if you like. This just stops that person plugging in what they want and potentially compromising the network. And then what about Ethernet wall sockets? They're open to anyone. Well, you could shut those switch ports down those outlets are connected to, and then turn them on upon request, or place those ports in the VLAN where you cannot even allow access out to the internet. These are a few ways to protect your network from unwanted visitors. Hopefully this video has provided enough explanation on 802.1x. Thank you very much for watching.